Hello, Triangle Proof family. Today we are going to actually jump in to completing some triangle proofs from start to finish. Then we're going to do that by learning something called SAS. So we're going to start though by just saying, you know what? If I want to prove triangles congruent, the best way to do that is to make sure that I have 3 pairs of angles that are congruent and 3 pairs of sides that are congruent. All right, so if we look at this diagram right here, they gave us some givens. And they're asking us to prove that TPR is congruent to QPS. So one of the things I want to say about proofs is usually when you're doing proofs, it's the idea that you know some information and you know, or at least you're trying to prove, that that information is supposed to lead to a conclusion, but you have to fill in the gaps. You have to push the first domino over and then say what happens next and next and next. All right? So one of the things I'm always going to tell you to do in triangle proofs is make sure you mark your diagram. So as I go through and read these givens, TR is parallel to SQ, fine. P is the midpoint of SR and TQ, fine. And TR is congruent to SQ. Okay, prove that the triangles are congruent. Well, right now, you only know that we can prove them congruent by finding 6 pairs of congruent sides and 6 pairs of congruent angles. So let's try to do that. We are going to set up a 2-column proof of statements and reasons, basically saying, here's what I think is true and here's why I think it is true, all the way down. Well, our first statements are going to be all of our givens. So TR is parallel to SQ. P is the midpoint of SR and TQ. And TR is congruent to SQ. And those are all given. All right, so I have one congruency statement right now. I got a pair of sides. That means I need 5 more because I need 3 pairs of sides and 3 pairs of angles. So let's see, what else can I say? Well, in the givens, they told us that, let's go with this side idea, P is the midpoint of SR. And in the last lesson, we said whenever your given includes a midpoint, midpoints create congruent segments. So if P is the midpoint of SR, that means SP is congruent to PR. Oops, not Q. SP is congruent to PR because midpoints create congruent segments. And P is also the midpoint of TQ, so I know that TP is congruent to PQ. And I can actually write those both in statement 2 because they have the same reason. So if you ever have 2 statements that rely on the same thing, they can go in the same numbered statement on the left and have the same numbered reason on the right. All right, well, I've done all the sides. Sweet. Now I got to work on angles. All right, number 3, let's go back to the givens here. They told us about parallelism. In the last lesson, we learned that parallelism usually creates congruent alternate interior angles, congruent corresponding angles, or maybe some supplementary same side interiors. All right, well, I have a zigzag going on here. I have one of those nice letter Z's right here. And if I see the letter Z, I know I have congruent alternate interior angles. One here and one there. So I know that this angle up here, you know what, I'm going to call it 1, and that angle down there, I'll call it 2, are congruent. Angle 1 is congruent to angle 2 because parallel lines create congruent alternate interior angles. And if you look on the other side, if I were to highlight this again like in yellow, I have a backwards Z right here. I got another pair of alternate interiors right here. I'll call these 3 and 4. So I can also say that 3 and 4 are congruent because I still have parallel lines that make congruent alternate interior angles. Cool. And then last but not least, whenever you see like an X inside your diagram, whenever you see what I call bow tie triangles, you're going to have some vertical angles. This angle right here and that angle right there are vertical angles, and vertical angles are always congruent. So for step 4, I'm going to call this, angle 5 and angle 6, and say angle 5 is congruent to angle 6 because vertical angles are congruent. All right, so I have 1, 2, 3 pairs of angles, 1, 2, 3 pairs of sides. I have all 6 parts. So now I can say that triangle TPR is congruent to triangle QPS because all 6 pairs of corresponding parts are congruent. Cool. Now, one other thing I want to mention here is the order in which I said it. TPR is congruent to QPS. You have to make sure that those line up. So if you ever had to write like a triangle congruent statement from scratch, you need to make sure things match. So T matches with Q. Okay, so T and Q are in the same position. Let's see what comes next. P. P is in the middle, and P is in the middle twice. And then R matches up with S, R with S. So just make sure your corresponding letters relate to your corresponding parts. Okay, if we had written that TPR was congruent to triangle PSQ, that would be wrong. Okay, so you can't write it that way. You have to go in the correct order. Now, here's the thing. The whole point of this lesson was actually to say that we never need to use this reason number 5 again. There's nothing wrong with it, but there's a shortcut, okay? So the shortcut is this, side angle side congruence criteria. Right above this, it says, now imagine that we erased SQ and TR. Would we still be able to draw them back in? And the idea there is that if I were to draw this, and not have the top and the bottom, I could draw them back in because I would really just be containing fixed endpoints already, okay? So let me explain it though in the context here. There is something called side angle side congruence criteria. Up until this point, we've said you need to have 6 congruent corresponding parts. Starting now, I'm going to show you shortcuts where you only need 3 corresponding parts, because if 3 specific parts are congruent, then everything else is going to have to be. And the first one we talk about is called SAS, side angle side. If you know the side of one triangle is congruent to a side of another side of that triangle is congruent to another side of the other, and the angle in between those sides, not just any random angle, the angle in between those sides calls the included angle. If you have 2 sides and the angle between them, that is good enough. And you can stop there and say, hey, if AB is congruent to A prime B prime, AC is congruent to A prime C prime, and angle A is congruent to angle A prime, those triangles are congruent by SAS. You don't have to find the other angles or the other side. Let me show you what I mean. So if we come back here and I say, okay, this triangle is supposed to be congruent to that one by SAS. What's missing? Well, I have S and S. I need an A in between them. That would be this one. I have S and S. I need an A in between them. That would be this. If this triangle is supposed to be congruent to that one, I have a side and an angle. I need the other side next to the angle. Side and an angle, the other side next to the angle would need to be equal. Okay. So if we come down here and I look at this picture, it says, given that LNM, this angle, is congruent to LNO, that angle, and MN is congruent to NO, prove that the triangles are congruent. Okay, well, if I want to prove the triangle's congruent, right now we have 2 ways to do that. Option 1, find all 6 corresponding parts. Yeah, we're not going to do that because option 2 is better. Find 3 pairs of corresponding parts that make SAS. SA, well, what other side would I need? I would need this one. Is that side congruent? Oh, yeah, it would be, because that's the side that's shared by both triangles. That's reflexive. So we can do this. We can do SAS with this. So I'm going to erase that for a second and go back to the beginning and say, all right, now that I have a plan, I know I can do it. Now I'm going to write it out. The measure of the angle is equal to the measure of the angle. The side equals the side. Why do I know that? Well, because they told me. So reason number one is given. Thing number two, if I'm supposed to prove these triangles congruent, I need to explain why ln lines up for both. So I am going to say ln is congruent to ln by the reflexive property. And then I'm going to say now I have a side, an angle, and a side. So now I know that triangle LMN is congruent to triangle LON by SAS congruence. Okay. That's how SAS works. You can prove triangles congruent if you can find side, angle, side. Did that. Now, the other thing we can do is say, now that I know that those are congruent, one must map onto the other by a sequence of rigid motions, some transformations. So how do I take the triangle on the left and turn it into the triangle on the right? Well, I'd fold it over ln. We do a reflection over ln. You don't have to do that step as part of a proof, but it's a nice way to link the last unit in this unit. Okay. Now, another couple things, I said this before, but it's worth saying again. If you want to do congruent or equals, just be appropriate with your notation. If you say a side is congruent to another side, you would put the bar over the side and the congruent symbol on top of your equal sign. If it isn't there, you could write that as AB equals DC. Congruence notation says things are congruent. Equals notation says that numbers are congruent. The length of AB is equal to the length of DC. It doesn't matter which one you use, but try to be consistent. All right. Angle A is congruent to angle B, whereas the measure of angle A is equal to the measure of angle B. So I just wanted to make sure you were aware of those notations. Okay. Doesn't matter what you use as long as you're consistent. All right. Now let's look at this next one. It says KM bisects JN. So this line right here cuts this other line in half. So I'm going to know that this line got cut in half. So those two parts are equal. L is the midpoint of KM. So I know that these are going to be equal. And then they want us to prove that the triangles are equal. Well, if those sides are equal and the other sides are equal, I could prove the triangle's equal by SAS if I knew that the angles in between are equal. Oh, and those angles are going to be equal by vertical angles. So yeah, I think we can do this. Now we have to justify it. I'm going to sneeze. Excuse me. All right, so let's write it out. KM bisects JN, L is the midpoint. That's my givens. All right, and then the first thing we marked is since KM bisects JN, I know that the two parts of JN are going to be equal. So I have to say that. I have to say JL is congruent to NL because a bisector creates two congruent parts. Cool. Then the next thing I marked was that KL is equal to LM because we knew we had a midpoint. So KL is congruent to ML because a midpoint creates two congruent segments. Okay, so one of those things was congruent because of the word bisect. The other thing was congruent because of the word midpoint. All right, and then we said, I got two sides. Now I need the angle in between. These angles in between are congruent because they're vertical angles. So I can say angle KLJ is congruent to angle MLN. Or if you don't want to use 3 letters, I am absolutely okay with it if you made that an angle 1 and angle 2. Totally fine. So KLJ is congruent to MLN because vertical angles are congruent. So we this, it was this, and that equals that. And then 1 equals 2. And I have enough for SAS now. So I can say that triangle KLJ is congruent to triangle MLN because of SAS congruence. All right. And then it says describe specifically the rigid motions that will map KLJ onto MLN. All right, well, let's see. I need K to come over here to M. You know what that would have to do? I'd have to turn this because K reflects through L to become N. J reflects through L to become N. That's a point reflection, also known as a rotation of 180 degrees. So we are going to rotate around point L 180 degrees. All right. I am going to leave this last one to do in class. If you wanted to do it right now and then check with me in class, that's fine. But we are going to save this one to do together. So I hope everybody is having an excellent day. I don't have any great jokes for you today. Let's see. What could I say? What do you get if you cross a snowman with Dracula? What do you get if you cross a snowman with Dracula? Frostbite. I know, it's terrible. Have a good one, everybody.